Hello, dear student. Welcome to you in my YouTube channel, Tomer Study Circle for IIT JEE and NEET Physics. इस वीडियो में हम दो प्रॉब्लम को सोल्व करेंगे जो वर्क एनर्जी थ्योरम पे बेस्ड है। नीट और जेईई एग्जाम में स्पेशली इस ट्रिक का इस्तेमाल करके आप वर्क एनर्जी थ्योरम का इस्तेमाल करके बहुत ही कम टाइम में आप इस तरीके की प्रॉब्लम को सोल्व करेंगे। तो अब हम प्रॉब्लम सोल्व करना स्टार्ट करते हैं। फर्स्ट प्रॉब्लम आपकी स्क्रीन पर दिखाई गई है। इसमें एक ब्लॉक है जो एक कर्ड सरफेस से रिलीज किया जाता है और ये कर्ड सरफेस क्या है, स्मूथ है, और ये वाली कर्ड सरफेस भी क्या है, स्मूथ सरफेस है। फ्रिक्शन यहाँ इन्वॉल्व नहीं है। एक इसमें 10 मीटर की एक लॉन्ग ट्रैक है जो हॉरिजॉन्टल है और ये जो रफ सरफेस है, और यहाँ पे कोफिशिएंट ऑफ फ्रिक्शन की वैल्यू 0.5 गिवन है। ओके, ये कह रहा है कि जब ये ब्लॉक यहाँ से रिलीज किया जाता है तो इस कर्व सरफेस पर ये वर्टिकल हाइट h पर आके रेस्ट में आता है। तो वी वांट टू कैलकुलेट द वैल्यू ऑफ दिस हाइट h। द प्रॉब्लम इज सिंपल, लेट द मास ऑफ द ब्लॉक इज बेसिकली m। लेट द मास ऑफ द ब्लॉक इज m। If you use work energy theorem, then work energy theorem states that work done by all forces W will be equal to the change in kinetic energy delta K. That is work done by internal force plus work done by external force plus work done by non-conservative force will be equal to delta K. Change in kinetic. Okay. अगर आप देखें तो बेसिकली इस रफ सरफेस पर ब्लॉक पर दो फोर्स एक्ट करेंगे। फर्स्ट फोर्स दैट एक्ट्स बेसिकली परपेंडिकुलर द सरफेस, दैट इज नॉर्मल रिएक्शन, एंड सेकंड इज इट्स वेट, दैट इज mg वर्टिकली डाउन। जब ये इस रफ सरफेस पे आ जाता है तो बेसिकली इस पे थ्री फोर्सेस एक्ट करेंगे। फर्स्ट वेट mg डाउनवर्ड, सेकंड नॉर्मल रिएक्शन वर्टिकली अपवर्ड, एंड फोर्स ऑफ फ्रिक्शन F डैश अपोजिट टू इट्स मोशन। ओके, अगर आप देखें नॉर्मल रिएक्शन जो है हमेशा क्या है, परपेंडिकुलर है डिस्प्लेसमेंट के, तो वर्क डन बाय नॉर्मल रिएक्शन विल बी इक्वल टू 0। दैट इज वर्क डन बाय नॉर्मल रिएक्शन will be equal to 0. Now we apply work energy theorem. The kinetic energy here at this point A, kinetic energy at A, Ka will be equal to 0, and the kinetic energy when block reach here at point B, kinetic energy here also 0. It means there is no change in kinetic energy, or we can write that delta K will be equal to 0. Okay. So here the weight act mg here, also at every point the weight act vertically down. Here this distance is 8 meter and this distance is h meter, hence work done by weight w will be equal to mg into 8 minus h. This is the work done by weight, and work done by friction Wf will be equal to minus of F multiplied by this displacement. This displacement is given as 10 meter, that is equal to 10. Okay, now we want to calculate the value of F. F will be equal to mu n, and n here is equal to mg, so we can write F will be equal to minus of mu mg multiplied by 10. Okay, on putting the value of mu, we can write this become as minus of 0.5 multiplied by 10 multiplied by mg, or we can write as W of friction force will be equal to minus of 5 mg. Okay. No. On putting the value, total work done will be equal to 0, that is work done by weight plus work done by frictional force will be equal to 0, implies that mg into 8 minus h will be plus 5 mg will be equal to 0. Sorry, this is minus 5 mg will be equal to 0, or we can write 8 minus h minus 5 will be equal to 0, implies that h will be 3. This is the answer. So we can solve very easily this problem using work energy theorem. We have applied the total kinetic energy, change in total kinetic energy equal to 0. That will be equal to the total work done by all forces acting on the body. Now we go to the next problem. The next problem is here. Again, a block is released from height h on a smooth curved surface. Calculate the maximum height reached by the block on ramp. This is ramp. Ramp is basically a rough surface and the coefficient of friction here is given as mu k. This is the angle of theta. Okay. If let the block reaches up to maximum height h here. Again, on curved surface, there are two forces acting on the block. One is its weight vertically downward and another is the normal reaction that acts perpendicular to the curved surface. The again work done by normal reaction will be equal to 0, and suppose the block reaches here, the work done by the weight will be equal to W due to weight will be equal to flat mass of the block is m, that is mg into h minus small h. This is first. Why capital H minus small h? Because this height is given as capital H and this is given as h. Hence the net displacement along the force that will be equal to h minus h. Is clear? When the block reaches at this ramp, again the force of friction act normal direction, right? Weight act vertically downward and this angle becomes theta because this is the theta. Hence this component becomes W cos theta. The value of n becomes W cos theta, or that will be equal to mg cos theta, right? Because the block move on the ramp, the value of normal reaction will be equal to mg cos theta, and the value of force of friction F will be equal to mu times n. Mu is here given as mu k into n, and that becomes mu k times mg cos theta. If this height is h, then let this distance is basically x. From this right angle triangle, we can write h by x will be equal to tan theta. Okay, this distance is h and this is x. From here we can write x will be equal to h cot theta. This is the distance covered on the block on rough surface. Hence work done by frictional force Wf will be equal to minus mu k times mg cos theta multiplied by x. Why this? We have taken negative sign because force of friction act downward to the plane and block is moving in the upward direction, right? On putting the value of x here, we can write minus mu k mg cos theta into h cot theta. Okay, right? This is the basically work done by the frictional force. This is 2. The kinetic energy when body starts from here, K1 will be equal to 0 because block is released here. Finally, block come to rest here at this point and the kinetic energy is that point will be equal to 0. So, change in kinetic energy delta K will be equal to 0. On applying work energy theorem, again we can write, on applying work energy theorem, again we can write here W due to friction, work done due to friction plus work done due to weight will be equal to delta K, and that is given equal to 0, implies that we can write here minus mu K into H into mg cos theta multiply by cot theta will be equal to plus mg into h minus h will be equal to 0, or we can write here as implies that mu K into h cos theta into cot theta will be equal to capital H minus h, because we cancel out, we can take mg as common and that becomes 0 divided by mg, that becomes 0. On simplifying, we can calculate here, that is h into mu K cos theta cot theta plus 1 will be equal to capital H. So from here we can calculate, implies that H will be equal to capital of H divided by mu K cos theta cot theta plus 1. This is the basically your answer. So we have solved this problem very easily by using work energy theorem within a very small time. For more such video, please keep watching our YouTube channel. Thank you for watching.